Maganda umaga sa inyong lahat. Good morning, everyone. In this video, we will be talking about the Linux file system and its structure. Important note, I do not mean a discussion about stuff like ZFS versus Btrfs, but more of a discussion about files and folders and how we organize them. While this series is about the terminal, these are critical concepts for understanding the functionality of the terminal and how to use it. These are also fundamental concepts for both the terminal and Linux in general. In addition, I want to cover some basics about storage drives and how they are set up. Again, files and folders, not file systems like ext4. This will apply to computers in general. I am going to do my best to keep it fairly basic. The hope is that it will provide simple context and basic understanding. In this video, for the most part, we are going to be using Console, which is the KDE terminal emulation program. We will also, on a few occasions, be switching over to Linux Mint Debian Edition and using the GNOME terminal in our virtual machine. This is mainly to highlight some differences between distributions. I want to apologize for the lateness of this video release. I was hoping to have it out a lot earlier, but a couple of things happened. It turned out to be longer than I thought it was going to be. Not to mention there were some real life intrusions as well. This is supposed to be retirement. And I was a little under the weather for a while there, but I'm here now and getting to it, so let's get started. Okay, let's talk file systems here. File systems is something that's on a storage device that allows you to save various folders and files to it. Most file systems require some sort of setup. Generally, if you get like a solid state hard drive or a mechanical hard drive, they've been low-level formatted at the factory. Then all that needs to be done is they need to be partitioned, and then the partition's formatted. Lucky for us, most operating system installers do this for you. We'll actually be talking about this a little later in the series when we get into formatting through the command line or partitioning through the command line. But once prepared, they can hold different structures, and I'm going to refer to these as structures. The two I'm going to mostly refer to, three technically, is the folder, the file, and the link. And these are what we're going to use to organize our file system. And when I say organize our file system, it's when you install an operating system, it will lay out a base file system organization. It'll consist of several folders under your root, and then how we're going to use that. I'm defining a directory or a folder, and the two terms are interchangeable. It's a container that holds other folders or files. Overall file system structure is going to be based on nested folders. You'll see that pretty quickly when you look at any of the, whether it's Windows or Linux. When you take a deep dive into the file system, you'll pretty much see the actual organization is based on nested folders. Files themselves, they can be anything from a simple text file to an image file to libraries to program files. There's really no limit to what type of information a file contains. Links is the other part of the organizational system. These are pseudo files or pseudo folders in one location that point to another. That is to say, they'll replace a file that would be in a certain location, and they will point to a file in a different location, or replace a folder, point to a folder. They're mainly used for compatibility with older style system software and for convenience reasons. Okay, moving on. So let's come up with an analogy for a file system. This is an oldie but a goodie, and that's a file system is equivalent to a filing cabinet. I know that was all we had when I was younger, but yeah, now we store things on computers. But we'll assume the file cabinet is equal to your device. If you have multiple devices, you'd have multiple file cabinets. The drawer in the particular file cabinet is equal to a partition on the device. You can have multiple different drawers, just like you can have multiple different partitions on your device. Folders and directories would be the actual folders stored within the drawers of the file cabinet or on your partition. And files are going to be the pieces of paper stuck in the folder. Well, on the computer system, they're not just pieces of paper, but you get the idea. And then links is going to be our yellow sticky note we attach to an empty folder that actually points or tells you to go look for the information in another folder. This would be equivalent to a link. So simple analogy, but keep it in mind when we're talking, okay? All right, since we're talking about people new to Linux, we're going to assume they're coming from Windows. So let's take a moment to discuss the file system on Windows. Windows uses what I like to refer to as a decentralized layout. At your top level or root level, you have a partition on a drive. This would be called something like C:, or D:, or E:. I would like to note that on some occasions, partitions are not visible to Windows if they're not formatted with NTFS or FAT32, FAT anyways. They may not be visible to Windows, so you could have extra partitions, they just won't show up unless they're in a file format Windows recognizes. We're going to assume we're installing on the C partition, and Windows uses 4 main folders at their root level. The Windows folder, which is where Windows actually installs. The Users folder, which is where our user directories and user information is. Then we have both program files and program files x86 for 64 and 32-bit programs. Within the users directory and or home directory, we will have some common folders like documents, music, video, pictures, things like that. And this will all be on the C drive, assuming that's where we installed it to, and that's most common. Windows has some advantages and disadvantages, and this is not a diss on Windows. It's all operating systems and all file systems, including the Linux ones, have advantages and disadvantages. So in Windows, when you install a program, you don't necessarily have to install it in the program files folder. You can pretty much install it anywhere. And your common folders can be moved. Anybody who's ever lost an OS and had all their user data on the same partition as the OS understands the need for keeping your user data on a separate partition, in which case it's easy to move those to, say, a D: partition where they should presumably be safe when the operating system fails. And again, not just Windows, but Windows, Linux, it does happen. For the average user, everything should end up being set up in the C partition or C drive. I mean, that's just the way it works for basic users. If you got to use anything else besides that, you're probably jumping in a little further than most users want to go. So that's the quick 20,000 feet overview of the Windows file system and its layout. All right, now that we've discussed Windows, let's move on to Linux. Linux is different in Windows in that it's all in one large file tree. You've probably heard it said that everything in Linux is a file. Under your root level, which is the top of your file tree, you're going to have 15 to 20 common folders, and this is going to be extremely dependent on what your distribution is. And this may seem overly complex, but I would assure you it's no more complex than Windows. If you dived into Windows window folder, you'd see there's a lot of different folders and a lot of different stuff in there, so complexity is a relative term. So the top of our file tree is a root partition. This is on a partition on a drive, and it's symbolized by the /. This is something that confused me initially when I first moved to Linux. The / is an actual folder. It's your root folder. And when you want to go to one of the top level folders, it's / folder name. It's a minor detail, but it's kind of important. You can also mount additional partitions or drives. They don't show up as a D or an E drive like they do in Windows. You would have to mount them to an empty folder on the file tree. Because Linux is open source software, distributions are free to do things the way they want, and they do. While most of the major components are going to be similar, we'll see as we go through this that if you go to 2 different distributions, the file system can be laid out slightly differently, and there are other slight variations below the surface. It's nothing major, but it's something to be aware of. Should also understand that the Linux file system is in continuous development. The file system we have today, and we're going to look at that in a minute, is going to look significantly different than it did 5-10 years ago. Freedom of choice is what makes a Linux a great operating system? It's what makes Linux great, and the distribution is your operating system. But it's also a stumbling block to many. Most people just want to install an operating system, have it work, and not have to do a lot of fuddling or make a lot of decisions or change things. Unfortunately, that's not Linux. Well, some of the beginner distros are nice, but you know what I mean. All right, enough informational stuff. Let's get into the terminal and play around a little bit. I think what I want to do first here is we're going to run a program in our console, which is in the KDE, which is part of Arch on my main laptop. It's called FastFetch. This is a replacement for NeoFetch, which is no longer being maintained. You can still find it in the Arch repository, and you can still find NeoFetch in most other repositories. You can still use it, but like I say, it's no longer maintained by the person who is managing it, but there's other alternatives like FastFetch. And these programs give you the cool looking displays. Well, I don't know how cool looking they are, but you see them all the time on YouTube and various websites. So we'll run it here, and we get the Arch Linux kernel version, KDE Plasma, and console, and some basic hardware information. Nothing we couldn't find out other ways, but they're kind of neat little programs because they give you like the ASCII2 art too. All right, let's go ahead and switch over to our virtual machine where we're running Linux Mint Debian Edition, and this is a GNOME terminal we're using here. And FastFetch isn't available in their repositories, but NeoFetch still is, so we'll go ahead and run NeoFetch here, and you can do a sort of comparison. And you can see you still get the same ASCII2 artwork and some basic information. There's not quite as much as there was in FastFetch, but all the basic information is still there. Host, VirtualBox, kernel version, Cinnamon desktop, GNOME terminal. Yeah, basically all the same information's there. So use NeoFetch, but like I say, as it gets older and less maintained, there may come a time where it doesn't work with the newer distribution releases. Then there are alternatives, though, and we saw one, FastFetch. Let's get back over to the console, that KDE console, that is. Now that we're back in console, I have another program I've loaded in called Tree. Again, it's in the repositories for both Linux Mint Debian Edition and Arch, and we're going to look at a tree display of the directory. And I'm going to jump back and forth again to show you the difference between the Arch system structure and the Linux Mint Debian Edition, or LMDE structure. So we'll type tree -L, one level, and the root folder, or top of our tree. And you can see we've got quite a number of folders here. I will point out, and we'll talk about this more specifically when we talk about the folders, that some of these are links to other places. The bin is a link to user bin as an example. We're going to talk about that later, but just see what's here and how many folders. So we're going to swing back over to our LMDE, and we're going to run the same command, tree -L --1 root level. And you'll notice we got a lot more files and folders here than we had in the Arch version. This is a Debian-based version, so there are some extra files and things in here. We've got multiple lib directories, a lot of different stuff, but the basic folders, most of them are still there, with the exception of media. We didn't have a media folder on the Arch side, but we've got one here on the LMDE side. And like I say, we're going to talk about all the main, most common folders here. So just hold on and we'll get to it. Let's look at the bin folder first. If we look at the listing using either ls-tac-l or the tree command, we can see that it actually is a link that points to a folder in the user hierarchy, /user/bin. If we cd to bin, that's change directory, and we use the pwd or present working directory command, it comes out as bin. This is the logical directory we're in. However, if we use the pwd or present working directory with the -p or physical directory, that's a capital P, it points to user bin. Again, /user/bin. I'm going to be leaving the slashes off, but they're in there as we progress.
If we do an ls, we can see there's a lot of files in here, and if we check our ls-tac-l or tree listing, we can see that also sbin points to user/bin. This is actually a recent evolution in the Linux file structure, as because of the way we boot nowadays, it's less likely to have a separate user hierarchy, so we can actually consolidate some of the files. However, that's not going to get rid of any of the additional directories. They still need to be there, or at least links where they are for legacy and for basically legacy programs. That's an entire subject. If anyone's interested, let me know, and we'll talk about the changes to the Linux file structure, but just be aware that bin is actually /user/bin, and we'll cover that again with sbin. Going alphabetically, let's look at the boot folder. This basically contains everything we need to boot the system. We'll use the double dot or relevant address to take us back up a directory and then go to boot. This is something else that'll be covered in a later video. I just thought I'd demonstrate it here. But if we do a ls-tac-l, we can see we have an init RAM-fs, which is their initial RAM disk file system, and we have vmlinuz, which is the Linux kernel. EFI is our boot system, and grub is our boot manager. Note the way I set up Arch here, EFI is not really mounted at this point. We'll mount it if we need it, but it doesn't need to be mounted. Some systems set it up to have it mounted all the time, but again, that's up to you. Again, that's a subject for another video if anybody's really interested. And the grub directory holds all the grub configuration files. Dev is our next folder. Dev is short for devices. In this folder, we'll find a list of files referencing all the basic devices on our system. These are things like hard drives, floppy drives, CPU, etc., etc. Everything in Linux is a file, and the dev folder is where files representing hardware are found. You'll be visiting this folder if you're mounting new drives or CD-ROMs or what have you. That's generally the main reason people access this folder. Next, we want to look at the etc or etc directory. This is where the system-wide configuration files get stored. In some early Unix manuals and documentation, etc is referred to as etc. It's Latin and so forth. But this is where all of our system-wide configuration files reside. It's up to the application writer where they store their configuration files, but a lot of them are kept here. So the etc directory or etc is where you're going to find configuration files. Okay, our next folder is the home folder. And within the home folder, you're going to find your home user directory. And since there's only one user on this machine, there's only one directory within the home folder. Within this directory, you're going to find a lot of standard folders or directories, documents, downloads, music, pictures, public, videos. This is similar to the standard default folders in Windows. I mean, there's a little difference, but it's basically the same concept. And if you've got local user configurations, they're also going to be stored in your local user folder as well, whereas the global ones were in etc. Next up, we have the lib or lib folder. There could be several different lib folders depending on your distribution. You could have lib, lib32, or lib64, or all three. Libs is where we store libraries, which are reusable segments of code. If you're thinking Windows, think dynamic linked libraries or DLL files. It's fairly similar. And these have been linked to the user/lib directory, as we saw when we looked at ls-tac-l or list-tac-l. And if we use the pwd or present working directory -p command, we'd see we are in user lib. And again, if we look at the tree command, we can also see that the lib and the lib64 are also in user/lib. Again, consolidation, if anybody's interested, that could be a subject of another video. We're going to jump over to the LMDE to look at the media folder. This is a place to mount external or removable media drives. It was used in the past for floppies, for CD-ROMs, and for USB devices. And again, it's not found in every distribution. It's here in LMDE, but it's not in Arch. If you look inside media, you'll see an RT folder, which is a user folder. So if I mount media as a logged in user, that's where it ends up. Arch just uses the user home directory and folders in there to mount media. So again, it's a little different. You may have a media folder, you may not. It's going to depend on your distribution. Next up, we have the mount folder. This is a generic mount point for pretty much anything. If you're installing a new hard drive or whatever, if you ever saw any of my Arch install videos, we use the mount point to mount there. You can actually mount USB or CD-ROM there too. It is basically a generic mount point. There's nothing in the directory, and it's available if you want to mount something there. Sometimes distributions do a lot more with mount than that, but the main purpose of mount is just a place. MNT is just a place where you can mount various partitions, drives, stuff that's not automatically mounted. A lot of times it has the same function of media, but another example would be, for instance, I have a remote Samba server, so I can mount a Samba share here as well to temporarily move data back and forth. So that's /MNT. It's a general mount point for pretty much anything. Next up, we have the OPT or options folder. This is a place where you would put stuff, binaries, programs, stuff that's not part of your distribution's libraries, something that's external that you installed yourself. You most likely would install it. Well, there's other places to install it, but if you're installing it at the main level, you'd probably install it in the options folder. On the Arch system here, we have an Intel package installed in options that came from Intel, and it's, like I say, it's not one of the actual packages out of the Arch archive, specifically the one API. It gets mounted here in options. Again, technically not part of Arch. Proc is our next directory, and it's short for process information. This is a virtual file system, and this basically exposes information from the underlying system where we can look at it. We can use commands like cat to look at physical files within the, or virtual files, we can use commands like cat to review virtual files. For example, we can find the CPU info file, and if we do a cat command on that, it'll give us all the information about our CPU, all 19 processors. A lot of other commands, especially in GUIs, call information from this directory, like, for example, the KDE info command. If you're looking up your CPU, it's going to call information from this particular file here. And again, this is a virtual file because it's a virtual directory. The root directory or folder is the home folder for the administrative user called root. This account may or may not be disabled depending on your distribution. You can't log into it directly as it belongs to root. There are some ways to get in there, but again, this is the administrative account for the root user. It's their home directory, which is separate from all the other home directories on the system. Generally speaking, as a system user, you will not be going into this folder, and you'll be using sudo for any root access you actually need. The run or runtime folder holds temporary data that's been created since the last boot cycle. It's all temporary data. There's a couple other places we hold temporary data, but run directory or run information is one of those places. And all the information in this file should be erased upon reboot. SBin or system binaries is a folder that would hold, whereas bin would hold essential binaries installed to run the system, SBin would hold stuff installed by the system administrator to do their job. Again, this is a linked folder like bin, and it's linked to user bin. And again, this is consolidation of said files. But for compatibility and for backwards compatibility, we do need to maintain a link here. And again, we can do the same thing. PWD shows our logical directory as SBin, and PWD-P shows us in the user bin folder. Next up, SRV or services folder. This is an interesting folder. It's meant to house services provided by the system. This would be more in line with a server than with a desktop. If we look inside this folder, we can see that the system itself created the Arch system here, created the FTP and HTTP folders. I created the data and storage folders as mount points for additional partitions for data and storage. But yeah, services is services provided by the system, and we can look at what's mounted here. You can see server data and server storage. Generally speaking, unless you're running a server, you're probably not going to be doing anything in this folder, so it's a safe bet to use it for other stuff. Again, like I say, I'm using it here to mount additional drives. The SYS or system folder is another virtual file system. It's similar to the PROC folder. It exposes system information in the forms that we can use. It's a lot more organized in the PROC directory because it's been around a lot longer. You can poke around in here and you can look at various settings and information about your system. Next up, we have the TMP or temporary folder. This is another one of those temporary storage locations that hold data of non-permanent nature that needs to be deleted or cleaned out at some point. Mainly here it's user application data, but again, this is short-lived data and it should be cleaned out at some point. USR or user folder. This is a storage space for read-only data for the user. There's a lot of stuff in here. For example, if you have applications, they'll be stored in here. As we saw already, the bin and sbin and the lib directories are all shortcut to this folder. And actually, if you look inside the folder, we can see that lib64 is shortcut to the lib folder and sbin is shortcut to the bin folder. So we got a shortcut from sbin to user, sbin to bin. Yeah, I know it sounds a little complicated, but it works. We also have the share location, which holds a lot of shared information, including things like fonts, icons, and various other artwork and things like, for example, programs like GIMP will store their default data here in a particular folder by the same name. If you add plugins or brushes or pick maps to GIMP, they would probably go in a place in your user home folder under home/user. If it's meant to only be read-only, which a lot of the default software stuff that comes with it is, it'll be stored here. So again, this is user information. It's read-only. Most of your applications will be stored here. Most of your extra stuff that comes with your applications will be stored here, like fonts and like icons and like graphics. And finally, we come to the VAR or variable folder. This folder holds system data, user data that's meant to change over time. If you were on some distributions, if you're running a web server, they will store your web pages and other stuff in this folder. Mail spoolers get stored in this folder. Log files get stored in this folder. Just any type of file that's meant to change over time gets stored here. And again, if you do a ls-tacl, you'll see we've got a lot of shortcuts pointing to other places as well. So yeah, variables are last folder. And again, it holds one of the most important ones you'll want here is the log folder, which holds most of your log files. But that's it for our folder review. Okay, everybody, that's it for our review of the file system. If you want to look online, you can look up Linux file system hierarchy, and you can find more detailed explanation about all the folders and what they variously are used for. Or you can look in your distributions documentation, because like I say, this does change distribution to distribution, so just be aware of that. Again, sorry for this being late. I've been sick and I had a bunch of other things come up that prevented me from working on this. But I want to get this one out because it's important, and it's important for our next steps in this series. A lot of information was thrown at you here. It's a lot longer than I expected it to be, but I hope you find it valuable. As always, like, comment, subscribe. Let me know how things are going, what you want to know about Linux, the terminal. I'll be happy to try and accommodate you. Thank you. Bye.